Okay, so this is going to be a review of the Chapter 2 exam question number 1. So we're going to go through this problem and talk about where the points are awarded um, and how you should have done it. So here is the question. You may have a different version of this question. There are several different versions. So your equation may be different, but the questions are the same and the points are all awarded the same. And I'll show you where you can find the literal solutions to your problem at the end of this video. So we're given a function and we're supposed to use it to answer all of the following questions. So we've got a part A, B, C, and a D, and each of these 4 parts ask us to find a limit at a different point. And in all cases, we're supposed to show the work that leads to the answer and simplify the result. So to take part A, we're supposed to find the limit of h of x as x approaches 1, show the work, and simplify the result. So the very first thing you should do with any limit is you should plug in the number and see what you get. So if you plug 1 into this function, you should get these numbers. And if you calculate this all out, that becomes negative 16 over 72. And if you simplify that fraction, you get negative 2 over 9. And that's the right answer to this question. That's what you should have done. So there are 2 points here. There is 1 point for substituting in a correct value. So putting the number 1 in the right place in the equation gets you 1 point. And then if you can then pull off the calculation and get the right answer, that's the second point. So pretty straightforward in part A. Part B asks basically the same question, but at a different value. So this is asking for the limit of h of x as x approaches negative 5. So again, the first thing you ought to do is plug in negative 5 and see what happens. And if you plug in negative 5 to this equation, you'll get a 20 in the numerator, but the denominator equals 0. And when this happens, this is information that helps you understand what the limit is. This number doesn't exist. So you should realize that there's a vertical asymptote. When you get a constant divided by 0, that's implying a vertical asymptote. And so where there's a vertical asymptote, by definition, this limit does not exist. Or you could also interpret this a little differently. You could say there is an infinite limit at x equals negative 5. The book uses that language, and so that's an accurate description of this limit. So either of those 2 answers is correct. Now you get 1 point for substituting in the correct value again. So putting negative 5 in the right place in the equation is worth 1 point. And then if you calculate those numbers and you come up with a 0 in the denominator, and then you got to interpret that result as either an infinite limit or as a limit that doesn't exist, that gets you the second point. So you could say it either way and still get both points. What you can't do is you can't say that the limit equals infinity because that is explicitly not true for this function. With a vertical asymptote at x equals negative 5, this function has one side of that vertical asymptote goes to positive infinity and the other side goes to negative infinity. So those two-sided limits, those 2 one-sided limits do not equal each other. So you cannot claim that the limit equals infinity. That's a wrong answer. Another thing you can't do is just stop after you say there's a vertical asymptote, because that doesn't answer the question. It's accurate, but the question was find the limit. And if the question is find a limit and you say there's a vertical asymptote, you haven't actually found the limit. You got to go one more step to finish the problem. So another issue that came up on this problem quite a bit is people made a mistake in substituting the correct value. So for instance, if you plug positive 5 into this equation, you're plugging in the wrong number, so that you're out of the first point. And unfortunately, if you do that, you're not going to get a divided by 0. And the purpose of this question is to see if you can understand what it means when you get something divided by 0, that's a vertical asymptote and that limit does not exist. And if you plug in the wrong number, you don't get to that part. So unfortunately, that's going to cost you both points. Okay, in part C, we're looking for the limit of h of x as x approaches -3. And again, we want to show the work and simplify the result. So the first thing you should do is plug in -3 and see what happens. And in this problem, um, you get a 0 in both the numerator and in the denominator. And what you need to be very careful about when this happens is how do you report this result? So once you realize what's going on here, oh, I've got 0 on the top and 0 on the bottom, this is the indeterminate form 0 divided by 0. And that has special ramifications. There's one point for doing this, for plugging in the correct value and obtaining the indeterminate form 0 divided by 0 is worth 1 point. However, as we talked about pretty extensively in class, it is not correct to say that something equals 0 divided by 0. The indeterminate form doesn't equal anything, and so it is a it is a specific um, error to claim that something equals 0 divided by 0. So on your paper, for this response, if you have equals 0 divided by 0 written down somewhere, you don't get the first point because your notation is wrong. And that's technically a false statement. Um, and that's a pretty strict point. So um, remember, don't ever say that anything equals 0 divided by 0. The proper thing to do is to calculate the numerator and the denominator separately. And you can claim, you could write them down as limits, or you could just write them down as calculations. Either way was okay. But you can't just say that anything equals 0 divided by 0. Okay, once you've decided that this is an indeterminate form, you then need to choose a strategy for solving the indeterminate form. And we learned several in class, and the first thing you probably ought to try is to factor the expression. And so in this case, you can in fact factor these two polynomials. And the important factor to get out of it is the x plus 3 on the top and the x plus 3 on the bottom. That's what's causing the indeterminate form. Now, if you attempted to factor, that is worth a point. So if you realize that, oh, what I should do to this is factor the expression, and you tried to factor, you get 1 point. Now, if you factored correctly, you get the second or the third point. It's possible to try to factor this and fail to factor it correctly and still be on the right path. So it's possible to get a second point here for trying to factor even if you come up with the wrong result. And then once you've factored, you should cancel out the x plus 3's, and you get x minus 5 divided by 3 times x plus 5. You could factor this in a different form. You don't necessarily have to factor that 3 out of the bottom and still be correct. If you have the successful factor or the correct factor, you get the third point. And then now that you've canceled out the x plus 3, you can plug in x equals -3, and you can get an answer. And in this case, it's -4/3. So that is the answer, and that is worth 1 point. So there are 4 points in part C. If you claimed that something equals 0 divided by 0, you don't get the first point, but you can still get all 3 of the rest of the points by doing this problem correctly, even if you've got that notation error at the beginning. All right, and then the last part, part D, is asking for the limit of h of x as x goes to infinity. And so what you need to realize here is that x going to infinity, a limit at infinity, is a horizontal asymptote. And so if you interpret the question as being what's the horizontal asymptote of this function, that's the equivalent statement. And if you look at this function for h of x, the way to calculate a horizontal asymptote is to look at the degrees of the functions. And the top function is x squared and the denominator function is x squared. They have equal degree. And there's a rule that says when you have equal degree, the horizontal asymptote is the ratio of the leading coefficients. And so in this case, that's a 1x squared on top and a 3x squared on the bottom. So it's 1 divided by 3. And this is just 1 point for this answer. It's either right or wrong. So the total problem is worth 9 points. Remember, this is graded on the on our AP Calculus conversion scale. So if you don't know that scale, you can find it in the resources folder. Look in the syllabus, and you can find the conversion scale. Um, and you should make sure that you check your answer as it's reported in Schoology out of 9 points, and then compare that to your score that's entered in Infinite Campus to make sure that it got transferred correctly. Um, and if it didn't, send me an email and just say something like, could you double check my score in Infinite Campus on this problem? Um, and I will see what is the issue. Now, if you have a different problem, a different version of this question, you can find the specific results to it in a file that's also in the same. It's in the same Schoology file as this video, so you should be able to find the scoring guide for the whole test. Um, the first several pages are just you can just scroll past those, but the second half of this document is the scoring guides, and it looks like this. So here's one for a second version of this question. You'll notice the layout of the problem is identical, so the approach to solving all these equations is the same, but they have different numbers and different answers. Um, but the 9 points all work out the same way. So you should be able to look at your response, follow along with the rubric, and see if you can come up with the same points. All right, so if you have any questions, you can certainly send me an email. Um, you should make sure you double check your score and make sure it got entered correctly. Um, and I will talk to you later. Thanks.